Among the most overlooked innovations of the Cold War is a device that quietly kept some of the most remote outposts on Earth alive. While spy planes soared overhead and radar networks stretched across continents, there was another battle being fought far from public view. A battle against the Arctic itself. In a place where temperatures could plunge so low they cracked steel, where darkness lasted for months, and where storms erased entire landscapes overnight, normal technology didn't just struggle. It failed outright. Batteries froze solid, fuel thickened into useless sludge, and generators either seized or made too much noise to operate safely. Yet the missions in these regions, early warning radar stations, reconnaissance detachments, weather teams, and isolated research groups, depended on power to survive. The Cold War demanded a machine that could endure conditions where almost nothing else could. And incredibly, engineers found the solution in a principle older than modern electricity, transforming a basic law of physics into a tool that still works today. This device was the Cold War field thermoelectric generator, a rugged, simple, solid-state power source that turned temperature differences directly into electricity. To understand why it mattered, you have to understand the Arctic problem. The region wasn't just cold, it was a technology graveyard. Chemical batteries, which rely on reaction rates, lost their capacity within minutes in severe cold. A radio battery that could last a day in warmer climates might die before a transmission could even be completed at -40 degrees Celsius. Solar power was useless during the long polar night. Fuel-powered generators needed constant maintenance, clean fuel, and warm conditions to start reliably. Luxuries that remote teams simply didn't have. And wind systems jammed with ice or suffered mechanical failures. The Arctic was an environment that punished anything with moving parts or liquid fuel, for early warning stations spread across Alaska, northern Canada, and Greenland. Even a brief loss of power could blind a section of the radar network. And during the Cold War, losing communication wasn't just inconvenient. It was a strategic vulnerability. The solution came from the Seebeck effect, discovered in 1821, which states that when two different conductive materials experience a temperature difference, they generate an electric current. For most of history, it was a niche scientific curiosity, but in the Cold War, it became a lifeline. Engineers realized the Arctic had something unique: endless cold. If they could supply a small, controlled heat source, they could create a massive temperature difference across a compact thermoelectric module and generate electricity reliably. Instead of fighting the environment, they decided to use it. Cold War thermoelectric generators were elegantly simple: a heat source on one side, the frigid Arctic air on the other, and thermoelectric materials sandwiched between. The greater the temperature difference, the more electricity the device produced. In other words, the harsher the environment, the better the generator worked. Despite their simple appearance, these units were engineered with extreme reliability in mind. They were silent. They produced no moving parts to jam or break. They didn't require fuel deliveries, and they worked regardless of weather, sunlight, or ice buildup. They produced modest wattage, enough for radios, aircraft beacons, navigation instruments, lamps, or charging small batteries. But in remote Arctic operations, those few watts meant everything. When storms knocked out larger systems, or when temperatures fell below the limits of chemical power sources, thermoelectric generators simply kept running. Their reliability earned them a place in early warning radar shacks, remote weather stations, research camps, and even aircraft survival kits. Downed pilots in the Arctic winter could potentially survive because one tiny, silent generator kept their emergency radios powered long enough for rescuers to track them. The brilliance of the technology becomes clearer when you consider why everything else failed. Cold cripples equipment that relies on chemical reactions, batteries, fuel systems, engines, and it also attacks systems with moving parts by causing contraction, lubrication failures, or freezing. But thermoelectric generators bypass all of those weaknesses. They operate on solid-state physics alone. No pistons, no liquid fuel, no combustion, no reaction time, no oil, no gears. As long as one side stays hot and the other stays cold, electricity flows. This made them nearly immune to the Arctic environment and turned them into one of the most dependable pieces of Cold War field equipment. What's fascinating is that the same principle can be applied today with modern components. Thermoelectric modules have improved dramatically and can be used with simple heat sources, like a candle, camping stove, wood stove, or hot metal plate. The cold side can be exposed to snow, ice, winter air, or even a cold rock. Place the module between the heat and cold, attach a voltage regulator, and you can charge batteries, run LED lights, or power communication devices off-grid. In survival shelters, thermoelectric plates can be attached to wood stoves, with the cold side routed outward, generating power for as long as the fire burns. And in winter camping, these systems often outperform batteries because the severe cold increases temperature, differential, and therefore efficiency. Today, the same idea continues to thrive. Modern Arctic expeditions, remote researchers, bush pilots, and off-grid cabin owners still rely on thermoelectric systems because the Arctic has not changed. Batteries still struggle in deep cold. Solar panels still fail during long periods of darkness. Fuel generators still jam, freeze, or draw unwanted attention with noise and exhaust. Thermoelectric generators remain a staple because they don't depend on fragile supply chains. As long as heat exists, from wood, fuel tablets, alcohol burners, or candles, electricity can be produced. Some modern designs even integrate with rocket stoves or attach directly to camp cookware, generating power as meals are prepared. It's one of the rare Cold War inventions that remains not just relevant, but practical for modern survivalists. More than anything, the thermoelectric generator teaches a broader lesson about survival engineering. The most effective tools in extreme environments are not always the most advanced ones, but the ones least vulnerable to failure. Throughout Cold War history, you see this philosophy repeated in heating systems, communication designs, and even ration strategies. Simple, durable solutions that could not be easily compromised. The Arctic thermoelectric generator embodies that approach perfectly. It may not have looked dramatic or high-tech, but it was trusted because it worked when everything else failed. It turned the harshest environment on the planet into a source of strength rather than a threat. Even now, looking back at these units in museums or archives, they appear almost unremarkable. Just metal housings, heat sources, wires, and plates. Yet these humble devices powered radar stations, saved stranded pilots, and allowed remote teams to survive in conditions that defeated nearly every other technology of the era. They are proof that ingenuity often thrives, not in creating something complex, but in understanding the environment so deeply that you turn its challenges into advantages. The thermoelectric generator did exactly that. It transformed cold from an enemy into an ally. For those fascinated by Cold War engineering and survival technology, this story is a reminder of how many forgotten inventions shaped the world quietly, from the shadows behind every radar line, every outpost, and every survival kit was a web of devices designed to endure the unendurable. And among them, few were as quietly important as the generator that kept working while everything else froze. If you value deep dives into these overlooked technologies, there is a vast world of forgotten Cold War tools still waiting to be explored.